Okay, I'm going to make a couple comments on the last problem from 3.3 and then the first three in set 2 of 3.4. What I have is the cursor here to point out things. That's the way the technology is going for me at the moment. Okay, in number 10 here, we have that it's a contingency. It's very important to remember what this means. Contingency, sometimes true, sometimes false. Thinking about what you're doing, remembering what contingency means allows you to stop after the second row in this case, and that's quite significant. As soon as you get one true and one false, you have a contingency. If it's a tautology or a contradiction, that means you're going to have to go all the way through the table. You don't know that in advance. You keep going until you get a true and a false for the claim if you're trying to check for tautology, self-contradiction, or contingency. Just a little bit in terms of the operators, and we don't have an easy story here. Also, let me talk about efficiency. This whole claim here is an OR claim. Second part is fairly simple. It's just not Q. If we knew the second part, the second disjunct was true, that would be the end of the story, and it would be easy, but in both of the first two rows, Q is true, so not Q is false. So the truth value of the whole thing, granted that, is going to be whatever the truth value of the expression in brackets here is, which is not P or Q, comma, and R. For this calculation, we have R is true, not P is false, Q is true. That would make this expression here false or true, which is by definition true. So we wind up in the brackets, true and true, which is true, and I've written that here. I've written some, but not all of it. Again, as I said in the other videos, you should decide how much you should jot down and how quite you go about these. Second part is kind of easy here. We have R is false, so we know that the whole expression in brackets is automatically false. It's an AND claim, and the second part of it's false. That then gives us false or false contingency. All right, let's take a look at number 3 here. I was just able to print up an 8-row table, so it's not perfect. It should be a 4-row table, as I say over there. You can take a look at the still. But notice that we just have A and B, so for all intents and purposes, the first 2 rows here are the same, so I just did the first one. A and not B with A and B both true is false. Second conjunct is false. Once we have a false premise, we can't have all true premises and a false conclusion, which is what we're looking for, so I just scratched out the conclusion. Here in the third row, in the cases where we have A true and B false, we're going to get true and true, which is true. So we need to go on and calculate here. We got to pay attention to the order. B horseshoe A is F horseshoe T, which is true. And these other two cases, turns out A and not B is false, in virtue of A being false. So we don't have to worry about that there. Let me say one more time, make sure that you don't make this mistake, thinking that you have a case where all the premise is true and the conclusion is true, that makes an argument valid. That's not the case. Valid means that there's no way, no possibility for all the premises to be true and the conclusion false. So one instance where all premises and conclusion are true does not prove the argument valid. Okay, and number 5 here. I began to the left. Sometimes there's a smarter place to begin. This is pretty easy, simple calculation. However, it only gives false when we have T horseshoe F. A is true and B is false, so I get false in rows 3 and 4 here. The rest are true. But the way I did this is once I had the first premise false, those rows are dead in the water. They can't deliver all true premises and a false conclusion. So scratch those out. C and not B, that's hard for that to be true. We need both parts of an AND claim to be true. It's only actually true of the rows that aren't already scratched out in the 7th row right here. So that allowed me to scratch out a large part of the remainder of the table. Only one live row here, and for the third premise, here I have premise 1, premise 2, premise 3, conclusion. Those are my abbreviations for the third premise here. If not B, then A. That gives me T horseshoe F, which is false. So in the 7th row, I can't get all true premises, false conclusion either. No row gives all true premises and a false conclusion. The argument is valid. All right, now in number 8, I began with the conclusion. 2 reasons. One reason. It's not the simplest. The simplest is clearly B or A. The reason this is an or claim is going to be true in most cases, so I'm going to be able to eliminate all those cases where the conclusion is true. Remember, we're looking for all true premises and a false conclusion. Do the calculations for C or not B. Looks like this. Okay, so it's only the first and the fifth row that have a false conclusion. Those are the only live options, and that's where I get this scratched out and this scratched out. B or A is actually true. I went to the simplest one next here in rows 1 and 5. And I continued, I bounced over to premise 1, premise 2, particularly complicated, so I thought I would be efficient here and go to the first premise, which turns out false in the first row, so I scratched out right here. Then it did turn out true in the fifth row, and then had to go ahead and do the calculation for the large expression in the fifth row, and it wound up with T horseshoe F, which is false. And that in total means we have no row with all true premise false conclusion, and so we have a valid argument.